the width of the beam, d effective depth है. What is Fy? Fy is the yielding strength of steel. So you can get this AST here would be minimum area of steel. Whatever you get will be AST will be now 0.85 into B cross D divided by Fy. This is what you will get, and this will be minimum area of steel. So you can say it's AST minimum. So when you say it's AST minimum, you are getting it from here. अगर आपको ये मालूम है इसके dimensions B and D of the concrete beam, and if you know the yield strength of steel, and these things you will be knowing up till this point, so then you can proceed towards design. Now, why does the code say that there has to be a minimum area of steel reinforcement? Why does the code say that there has to be minimum area of steel? The reason for this is, जो मैंने अभी कहा, I'll again redraw the figure. You have a beam, and in this beam, you have one element which is taking the shear forces, that is stirrup. लेकिन मैंने आपको अभी दिखाया कि shear plane जो कि है that passes through the center, that's taking maximum loads. तो ये सारा shear plane जो कि यहाँ से यहाँ तक कट कर रहा है इसको concrete section को, there is shear forces through it, through that section. The maximum forces are through that section along the depth of the beam center पे. तो stirrup तो बिल्कुल इतना ही ले रहा है उसमें से. The area of the stirrup is only this much. Rest this यहाँ से लेकर यहाँ तक, this is concrete. So concrete is taking rest of it. तो concrete shear forces भी ले रहा है. Concrete is also taking shear forces. Apart from compression forces, concrete में shear forces भी develop हो रहे हैं. तो उसका ये मतलब है, you have to provide, number one, concrete is taking the shear forces. Secondly, the stirrups are taking the shear forces. Third, now if you realize there will be steel bars here, and there is certain amount of shear force here as well. But concrete is very weak at this point, यहाँ tension zone में. So it will not take even the shear forces, but there are certain amount of shear forces even at this point. So there has to be some amount of steel being provided here, ताकि वो shear forces be ले, other than the tensile forces, they have to take the shear forces as well. So that's why from research this has been found out that this much is the minimum area of steel that has to be provided in tension as well as in compression. Compression side में भी आपको steel उतना minimum देना है as anchor bars or as compression bars आपको देने हैं in order to take the shear forces at this point as well as at this point, because at this, on this face there is hardly any concrete left to take the shear forces because it's already acting in tension. तो आपको minimum steel देना है ताकि वो shear forces भी ले at this point. इसीलिए code says gives this formula which has come from the research, from the empirical models. तो ये equation code में दी हुई है. तो आपको minimum इतना steel देना ही देना है. Now if your steel, अब आपका steel किस पे depend करेगा? Tensile force, compressive forces पे और tensile forces पे depend करेगा. T and C कितना develop हो रहा है. Overall steel उस पे depend करेगा. लेकिन आप minimum उसके अलावा भी दे रहे हो. Why are you giving minimum? Because you have to resist the shear forces. So remember this, that we have to provide the minimum area of steel in this bar. Now, secondly, I just forgot about cover. One is your bottom cover. जब मैं आपको ये दिखा रहा था, this figure, you have this as the bottom cover. Then there is a side cover as well. ये line जो है, there will be side cover as well. And this side cover is also CE. And this is also CC, clear cover here. So you have CC as well as CE on the sides as well. Why on the sides as well? Because you also need, there will be exposure on the sides as well. So you have to provide cover on the sides as well. I forgot this to mention. So up till this point, we have discussed the cover for the flexural members. We have discussed the stirrup. Why is it important? And you have a hook in the stirrup. Oh, and that hook we provide at 130 degrees, from 90 degrees up till 135 degrees, sorry. From 90 degrees से लेकर 135 degree तक hook को हम देते हैं. Now, how do we provide that hook? Let me show you this. We provide it somewhat like this. And then there is an angle in between these, this angle and this angle. This will be the angle between these hooks. So this angle is 135 degrees. From 90 degrees up till 135 degrees. So you can provide from 90 degree से लेकर आप इस hook को 135 degree तक ले सकते हो. But for earthquake purposes, as per IS 456, it can be about 90 degree. This hook. But for earthquake purposes, you have to provide the maximum. That's as per IS 1893. उसके हिसाब से, which is the earthquake code, and IS 17320 probably. I forgot. I'll again recheck this. So as per that, you have to provide 135 degrees. It's provided towards inside of the, towards the core. This is now the core of the beam. It will not be provided बाहर की ओर hook नहीं खुलता है. Why so? क्योंकि load आपका, once the load is coming, the hook is like this, the load is coming right like this. So under the load, this will buckle down like this, these steel bars. So even if the deflection is happening, it will buckle down like this. So something like this and something like this will happen. So ये ऐसे चिमट रहा है. So if the hook is towards the inner side, it will not open up. If it's towards the outer side, with under buckling, the hook will open up. So you cannot allow that opening up of the hook. Similarly, for earthquake purposes, जब loads laterally आ रहे हैं, in this plane or like this into the beam, you, when it's towards inside, it will move like this. Similar, ऐसे ही ये अंदर की ओर जाएंगे, buckle towards inside, but it will not open up once it's towards the inner core. So hook has to be towards the inner core. Then there are considerations for hook का length. Hook की कितनी होनी चाहिए? The length of the hook has to be 6D से लेकर 10D तक. Now, as per IS 456, 6D, you can take, what is D? D is the diameter here of, it's not effective depth, so we can say 6 pi, and but this is 6 pi of stirrup and 10 pi of stirrup. So it's 6 pi S till 10 pi S, the length of the hook. So 6, what is phi S? Phi S is the dia of stirrup or of the ring. तो अगर stirrup 8 mm का dia उसका है, तो आपका hook minimum has to be 6 into 8, which is 48 mm, and maximum it has to be 10 into 8, which is 80 mm. इसकी length होनी चाहिए. Again, this is from, so this is from IS 456 and this is from earthquake code IS 1893. It's 17240. This is not 320, 17240. If I'm remembering it right, this is IS 1893 or IS 17240. तो ये इसकी लेंथ होनी चाहिए हुक की, मीन्स ये लेंथ. It has to be 10D as per IS 17240 or IS 1893. So we'll stop here in this class. We'll take the attendance. We'll continue from here in the next class.